Hello everyone, this is Dilip Chakravarti, belonging to cybersecurity department in IAR in Engineering College. Okay, today we are going to discuss about binary tree operations and the traversals that are present in binary tree. Okay, so as we all know that binary tree is nothing but which consists of maximum of two children. Okay, so it may be zero children, zero child, or one child, or two child. So we'll call it as a binary tree. Binary tree is a non-linear data structure where it consists of children. Okay, we are representing the information in nodes. We are representing the elements in nodes format. Okay, we will see what are the operations we are going to perform on binary trees. Okay, there are a lot of operations we are performing. So why we are going to see means a binary tree is a data structure itself. So as we all know, data structure is nothing but the way of organizing the data and set of operations performed on the data. Now we are organizing our data. How we are organizing? We are organizing our data in the form of trees. Okay, in a hierarchical fashion, we are arranging the elements. Now, what are the operations we are going to perform? Okay, so we are performing various operations on binary trees, such as search, insert, delete, and different things. Okay, we will see one by one. So first one is search. Suppose if you want to search an element, okay, so we are searching an element in a tree. Search is an operation that is performed on a binary tree to find a given key is in the tree or not. Okay, you are searching it in a tree. If it is found, then the search is successful. If the node is there in the tree, you will get it as successful. Otherwise, you will get it as unsuccessful. Okay, this is the first operation we are going to perform on binary. Next, insertion. Okay, so we can insert an element into the binary tree. So insertion is an operation that is performed on binary tree to include an element in an existing binary tree. So we are trying to include an element in a existing binary tree. Okay, a new element can be inserted at any position in a binary tree. Maybe I'm going to insert it as a left child, or maybe I'm going to insert it as a right child. Okay, so I need to consider where I need to insert. To insert an element along with the element, the node or element to which the new element is inserted, it, a child must be specified. Inserted a child must be specified where I need to insert. Am I inserting it as a left child? Am I inserting it as a right child? Okay. The new element either to be inserted as a left child or as a right child can also be mentioned. Okay. This is the second operation. Similarly, I can delete. I can delete an element from a tree. Okay. Deletion is an operation that is performed on a binary tree. Okay, I can remove an element from my binary. Okay, so next operation is merge. I can merge two trees, two binary trees. I can merge two binary trees and I can form it into one tree. Okay, so similarly display. I can display all the elements in the binary tree. Okay, so I'm displaying all the elements in the binary tree. What are the elements that are present in the binary? Okay, these are the various operations we are performing on binary trees. Okay, so if you observe, this is the binary tree. As I already told you, a tree in which every node can have maximum of two children is called as a binary tree. If you observe here, for each node, so it is having maximum of two children. Okay, it may be 0 or 1 or 2. Okay, so now let's see about another concept called binary tree traversal. So traversal, as we all know, traversal is nothing but visiting each node, each and every node in the tree. Okay, here binary traverse, I need to traverse, I need to visit each and every. From where I need to visit? Should I start from the first node? Should I start from the leaf node? Should I start from the internal nodes? So this is the confusion generally we get. Okay, so here we'll see how we are going to traverse a binary. Here it is given, unlike linear data structure, linear data structures like arrays, linked lists, queue stack, which has only one logical way to traverse them. So we'll be traversing from first to last. But here it is difficult. Okay, we can't say this is first and this is the last. So we can't traverse like that. Okay, so we'll be using some types. Okay, some techniques to traverse this bandit tree. So using recursion, the function will call itself on the left subtree. Okay, so now I can say there are three traversals in binary trees. So one is in order traversal, next is pre-order, and next is post-order traversal. When we say it as in order traversal, means when the root is present in the middle. Okay, so the order is left root right. Okay, so first we will scan the left subtree, then we will go to the root, then we will go to the right subtree. Okay, so here in the left subtree again we'll be having the left, right, and root. Okay, so that means every time we have to perform this left, root, right. That means so we are performing the same operation. We call it as recursion. Okay, so using recursion, the function will call itself on the left subtree, then prints the current value. Whatever is the current value, we are printing it, and then call itself on the right subtree. Similarly, we'll go to the right subtree and we'll be calling the same thing. Okay, so in order means, as I already told you, left, root, right. Uses of in order. In case of binary search tree, in order traversal gives nodes in ascending order. We'll be getting the nodes in ascending order. Okay, so observe this tree. So this is a tree. If you are trying to write in order traversal, so how you will be getting? So first you will go to the left. Okay. So again for left it is again there are left and a right. Okay. So that means 2, 4, 6. Okay. Left subtree completed. Then we'll move to the right. 2, 4, 6, 8. So for the right again we are having left root right. Okay. So we'll move to the 9, 10. Yeah. So next is we'll be getting like this. See, observe 8. We'll go to this 2. So then we'll go to the root. Then we'll go to the 6, right? Then we'll go to the root. For right subtree, again I'm going. There I found left, root, right. Okay, this is in order traverse. Okay, so I hope it is clear. So all the elements are in ascending order. Okay, so we are moving from left to right. So next is pre-order traversal. Pre-order traversal means root is present at the beginning. Okay, the order is root, left, right. Okay, root, left, right. So here also we are applying the same technique. We will be using recursion only. Okay, first we'll go to the root. We'll go to the left there. So for the left subtree again we'll be having root, left, right. We'll be applying recursion and we'll be doing the same pre-order procedure. Okay, we'll be doing the same thing. Using recursion, the function will print the current value. First, it prints the current value, calls itself on the left subtree, and then it calls itself on the right subtree. Okay. The result is that it prints the tree value in pre-order. So, what is the use of this pre-order? So, if you are using pre-order, so there in order, so our elements are arranged in ascending. Okay, we got the tree from left to right. Whereas if you observe this, the use of pre-order is to get prefix expression. So I said expressions infix, prefix, postfix. Okay, so expression which is nothing but which consists of operators and operands. Okay, so here this pre-order traversal is used to get prefix expression on an expression tree. Okay, to find out the prefix expression, we'll be using this pre-order. We'll see an example with the tree. Let us take a pre-order like this. So this is the tree he has given. So for this, what is my root node? So first we'll start with 8. Okay, so that is my root. Then I move to the left. For the left subtree, again there is left, root, right. Okay, so we'll be getting 4, and so we'll be getting to the left 2, and then we'll be getting 6. Okay, so totally left part of the tree is complete. Now we'll go to the right. For the right again it is root, left, right. Root is 10 and left is 9, and right is 11. Okay, so in this way I am getting the pre-order traversal for the event. Okay, so I hope it is clear. So just simple that first we'll traverse the root node, then we'll go to the left subtree. In the left subtree again we'll write the root node, we'll display the root node, then we'll move to the left, then we'll move to the right. Okay, so then third traversal is post order traversal. Okay, so here the post order traversal means left right root. Root comes after left subtree, right subtree, and root. Okay, here also we are implementing the same recursion. So first we'll go to the left using recursion. The function will call itself on the left subtree. Okay, first we'll go to the left, then calls itself on the right subtree. So again it goes to the right subtree and print the current value. So finally we are printing the current value. Okay, so the result is that it prints the three values in the post order. It prints the three values in post order. So what are the uses of post order? Okay, so sorry, post order. Post order traversal is also used to get postfix expression. For pre-order, how we got prefix expression. Similarly, for post order, we'll be getting postfix expression of an expression. Okay, so we'll see an example with a tree. Okay, we'll see that. See this tree. So which consists of the children for each node. So post order means left, right, root. Okay, first we will be going to the left subtree. Okay, left subtree means so left of 8 is 4, 2, 4, 6. Okay, this is left subtree, and right subtree is 9, 10, 11. Okay, so first we will move to the left subtree. Okay, observe this. First we are moving to the left subtree. So here first I have seen 2. So that is my left. So what is my right? It is 6. Okay, we'll go to the right. Okay, then I am going to display the root. What is the root for 2, 6? It is 4. Okay, then left completed. So then I need to move to the right. I should not display 8. Okay, so I will go to the right. Okay, for right again we are having left, that is 9. Then I'll go to the right, it is 11. Okay, the root of 9 and 11 is 10. And finally, the roots of this subtree are 8. Okay, so in this way, I'm traversing my tree. Okay, either I may use in order traversal, pre-order traversal, or post-order traversal. I hope it is clear to all. Okay, so binary we'll take something binary tree using given pre-order and in order. So sometimes it is given pre-order and in order traversal. So they will ask you to construct a tree. Okay, so or sometimes they'll give post order and in order traversal. So they will ask you to construct it. So in order traversal should be must and should. Suppose in order is not given, if they give pre-order and post order, and if they are asking for a construction of a tree, means you won't get a unique tree. So at the time you'll get different trees by using those travels. But if it is given one in order traversal, so you'll be getting a unique tree. Okay. Now observe this. It's a very simple and a very interesting one. So in order, pre-order and in order is given. So here it is. These are the nodes. These are the nodes. Similarly, in order traversal nodes are this. Okay. So what do you mean by pre-order? Pre-order is nothing but root comes first. That means so which is root here? G is my root. Okay. So I got information that G is root. Just I am placing that one as a root. Okay, then so then observe. So next, so in order means left root right. So where is root G? Where we are getting here in order? So here we are getting Z. That means this part is left and this part is right. I hope it is clear. Okay, so in order means left root right. Okay, so we are placing this root here. So this is the left, that is QBKCFA is left and PDHR is right. Okay, so again for this, so you need to find the root. Among these, which one is coming first here? Observe here. So QBKCFA, QBKCFA, which one comes first? So we are getting B. That means B is my root node. Okay, B is my root. Observe here. So B is my root node, and in order. So the left of B is Q, and the right of B is KCF. Okay, we are just writing it. B for B, the left is Q, and right is KCF. I hope you are getting it. Okay, so similarly here also I need to find the root PEDHR. So in this, which one comes first? Observe here. PEDHR. PEDHR. That means P is coming first. That means P is the root node. Okay, P is the root node, and the left of the right of P is EDHR. EDHR. That means there is no left subtree for P. Okay, I'll be getting like this. Yeah, if you observe for this one, for KCFA, so he is calculating the root. Okay, among KCFA, which one comes first, ma? KCFA. A. So A comes first. That means A is my root node, and the left of A is, so KCF is the left. Okay, so A comes here, and the left is KCF. A comes here, and the left is KCF. For KCF, again, which one is the first? KCF. That means C comes first. Okay, C comes first, and K is the left, and F is right. You will be getting it as C is the root, and K is left, and F. Okay. So similarly for PDHR, already we have seen. So among this, P comes first, and DERH all are next to that. Okay, among this, P is the root, EDHR is the right side. You'll be getting like this. Okay, for P, the right is EDHR. Similarly for EDHR, so which is the root node? EDHR, observe there, EDHR. So D is the first. Okay, D is the root node, and left of D is E, right is HR. D, left is E, and right is HR. Among HR, which one first comes? So R comes first, and left is H. Okay, so R is my root, and left is my H. Okay, so this is about your construction of a tree using the pre-order and in-order traversal. Okay, similarly we can take another example like this. So where he has given two or in order and post order. In earlier example we have taken in order and pre-order, but here we are taking in order and post order. Okay, so observe here, first given in order. So and post order means we all know root is the last. Okay, left, root, right. So that means root is 1. So we are writing 1 as a root, and what is left and what is right we need to see here. So 1 is here, left part is 4825, and right part is 637. 4825 637. Okay, similarly for 637, so which is my root? Observe here for 637, so which is the last we are getting 637. So 3 we are getting 3 as last. Okay, so 3 as last, that means 3 is my root node, and if you observe in order, so 6 is left and 7 is right. Okay, 3 is my root, and 6 is left, and 7 is right. Okay, similarly 4825, for the 4825, so which comes last? Observe here, 4825, so 2 is coming last, that means 2 is root. So observe this 2 in order. So we'll be putting here. So 48 comes left, and 5 comes right. Okay, 2 is my root, and 48 left. Okay, 5 on right. Similarly for 48, So which comes last mark? 4 comes last. Okay. So in order, right side is 8. That means 4. The right subchild is 8. Okay. In this way, we are going to construct the tree if in order and post order is given. Okay. I hope it is clear. Okay. So thank you.